I was thinking, well, maybe we could just correct the ones that are right, but it's very confusing. So here we go. So we got 2 over x plus h minus 3 over h. We're going to start fresh here. Okay, the common denominator is x plus h times h. Now, the reason it's that is because these are really in parentheses and there's no numbers that are the same. There's no like exponents that are the same. It's very different than what we actually did. But what you have to figure out here is what's missing in each. So like in the first one, there's an h and an h missing. Would you agree with that? The bottom doesn't have an h, so we multiply
Yeah.
the top and bottom by h. Okay, so that means the top becomes 2h. Now on the right, it's kind of the same thing here. This h on the under the 3 is missing an x plus h, which means the top also needs an x plus h.
Right.
So that means that in down here in the second numerator, it's 3 parentheses x plus h with a minus.
But I thought, hang on, I'm trying to figure out. Oh,
We
I get it.
didn't do one like this from what I recall. The sheet was more about factors, not this x plus h business, which is it's more of a calculus concept.
Yeah.
So okay, so from here, this subtraction really it's -3, and that's what you're going to distribute to both.
Right. So it would be -3 plus negative, no, not plus, -3h.
-3x minus 3h, and you got a 2h.
Oh, over x plus hh. So it would be
So that
negative h minus 3x
exactly,
over.
yes.
Okay.
-h minus 3x over x plus h times h.
Okay.
All right. We'll look at the next one here. That's it for 1a, by the way. There's nothing more for that one. 1b, 2 over x plus h minus 1 over h over x over h. So it's really two separate problems. It's really like figuring out the numerator, which is very similar to the previous problem, and then dealing with the denominator. So we're just going to focus on the numerator. So just like in the last problem, the common denominator is x plus h times h. But you wouldn't know that unless you did the first one correct. So that you had no chance on part B. So don't beat yourself up if you didn't, because you had no chance. I mean, it just wouldn't have worked out. So the 2 over the x plus h is missing the h and the h. All right, and then x plus h for this one on the right. And that produces 2h minus 1 times x plus h over here. Okay, so just like the previous problem, you're going to distribute that negative to both. So it's going to be like 2h minus x minus h in the numerator, like that.
So it would be h minus x again.
Yes, yeah.
Yeah.
So it's h minus x over x plus h times h, but then we finally bring down this thing that we've been neglecting the whole time.
So would you multiply by h over x?
Yes.
Okay.
And I'm going to reframe this because it's a little bit off to the right here. So you do get some cancellations, and in the numerator you also get cancellations, but it ends up being h minus x over x plus h times x.
Hmm.
And that's it. That's your final answer.
Okay. So I'd have to get a right to get this right?
That's correct. Yeah. And we can argue about the merits of that. I mean, I don't like it particularly, but I mean, if you swim a team event, right? The first person does something wrong, it affects the rest of the team. I mean, this isn't a team test, but it's not totally unfair, but it really, works against you as a student, in this case. All right, ready to go on to 2A?
Yeah.
Why is 2B have a JZ in there? Why? I mean, that's just, I mean, what do you think as a student when you see that?
I just try to move on from it.
Okay. Right now, when the instructor says check, the implication there is that when you check your answer, it will not work. Do you recall that we attempted to determine what numbers to exclude before moving through this type of problem?
Yeah.
And if you don't, I'll just remind you that it's the numbers are wherever you divide by 0. So like setting the denominators not equal to 0, basically.
Okay.
So it's like saying x. Let me do it off to the right here. It's like saying x minus 5 cannot equal 0. So x cannot equal 5. X plus 1 cannot equal 0. So x cannot equal -1.
Oh, right. I remember that.
Yeah, well, timing is everything, right, in life. So um, the rest of the work, though, appears to be really solid on here. So everything else is right. Let me just check it. X plus 1, x plus, yep. 4x plus 1, 2x plus, yeah. So your work is correct. So you did all the work and you got x equals 5. And you're really happy about that. Okay, but it's excluded.
Yeah. So would I have to like
The only
how
thing
would
you need to add is the domain restriction for this.
Oh, okay.
But I'll add in, there's a little bit more that you can do to check this.
Okay.
So the other thing you can do here is you could attempt, like your instructor showed you there, is to check But you don't have to get very far. You would say, okay, check x equals 5. So you would start substituting into this equation. So you would say, okay, it's 4 over 5 minus 5. And you would say, cannot divide by 0.
Okay. That
And
makes
that
more sense.
and then you're done. Like you could keep going and saying, yeah, let me put it, you can just say dot 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 or something. I mean, the first one tells you like that's bad.
Yeah.
All right, let's look at 2b. And it says, okay, x equals -1 is a solution to x minus 3 over x minus 3 over x plus 1 plus 3 over x squared plus x equals 0. So the inference here is, again, that you're going to substitute this number in for x wherever you see an x. So this one you get a little bit further because it's -1 minus 3 over -1 minus 3 over -1 plus 1, but that's your problem because again, you cannot divide by 0.
Okay.
So you could say that JZ is wrong if you want.
Okay.
I don't know. I just think the math teacher's place is to try to be culturally relevant. I mean, I'm not even sure JZ is culturally relevant to you guys.
Not really.
Not really. Yeah. All right. So let's go to the back side of that page. Number 3, identify the slant asymptote and behavior. Okay, great. So let's do 3A. We covered this too. It's like we're really, really close to getting, probably another, like, out of on your score, really close to getting an extra 1 to 1.5 points on this, I think. Unfortunately, it just didn't pan out here. So you've started this problem correctly. I like that you put the 0 in at the end here. This is all great. And then you got the X down. That's all of that's correct.
So where did I go wrong with
Well,
the
let's look here.
two?
So x times x is x squared. X times -2 is -2x. And then you change the sign, so it becomes minus and plus. I think we're going to see it right here. When you add, it's 0, but then it's 5x here. Nope, you have that. Okay. So you want to get 5x from the x. You want to get 5x from this x. How do you do that? What do you multiply x by to get 5x?
What do you mean? 5.
5, yeah. So it could have just been that you saw the -2 and I don't know, you just thought that that was the number to put there. You correctly stopped multiplying at this point because you actually don't need to keep multiplying, which is good. Did you have a graphing calculator for this?
No.
Okay, so that would have been the other way to sort of figure this out. Yeah, so your your graph, though, just will remind a few reminders here. Okay. This has a slope of 1 and a b of 5. So slope of 1 means it's going to go up and to the right on your graph.
Okay.
And you went down and to the right for, it doesn't matter, but that's why the instructor circled it.
Okay.
All right, so let's talk about the graph of this. I guess that's also part of this. So x plus 5 was our equation here. That means you got to go up 5 and get your slope there, so you can get that dashed line in like that. So you correctly identified the oh, I don't have the question, sorry. You correctly identified the vertical asymptote. So the original function has a vertical asymptote at 2. You got that down correctly. And then you correctly determined the x-intercepts. You factored the numerator x plus 3. So you knew that it crossed at 0 and -3, like that. That was good. So this is pretty good. I mean, you really, I mean, it was getting like really close here. The fact that the fact that you got these two intercepts helps you to figure out what happens in these other regions. And then what you had to do is remember that it was always opposite. So the other graph would be up here in the top right. But your slant asymptote wasn't going the right direction, so there was no chance on that. But it really a lot closer than 1.5. I mean that kind of indicates you don't really understand anything about this problem. I think you're much closer than that suggests. Any questions on what we've done so far before we go to domain?
No, but for the domain, would you put oh my God, I can't think. Would you put the restriction?
Yes. Yeah. I mean, that was one way you could do it. You have to say that x cannot be 2. Is that
Yeah, that makes sense.
all right? Now for x-intercepts, kind of our last thing here. I already did on the graph, but you're setting the numerator equal to 0, and you had already factored this, which was great. Like that's exactly what you need to do. But you have to set each term, each factor equal to 0. So that means setting x equal to 0 and x plus 3 equal to 0. When I look at your work, I think I see maybe a transcription error more than anything. I don't because we did this a bunch of times. So x equals 0 and x equals -3. Those are the x-intercepts. And you wrote them as ordered pairs. These are the correct ordered pairs for this one. A lot happens when you're under a stressful situation. Sometimes you can't explain it very well. It just doesn't go the way you want. Y-intercept looks good. In terms of like you substituted in 0 for x. That was really good. You found f of 0, which was 0 squared plus 3 times 0 over 0 minus 2. in the numerator, you would have gotten that that's 0 over -2. And I don't, somehow you wrote -2 instead of 0. That's the big issue with that one.
Okay.
It, but like it's all kind of there. It's not like you left it blank and you had no idea where to start. You started all these problems correctly. So that means that when x is 0, y is 0, notice these are the same. This is
Yeah.
one of those things where if you do this enough, you notice these patterns. You're like, oh, if there's an x-intercept that goes through 0, 0, that's where the y-intercept is.
Hmm. Okay, so it's like, so I'm just kind of getting lost halfway through the problem.
I think that's kind of rough. I think you actually know what to do. I think it may have been the first time you really had to, do something on your own, and you're much closer than you would think. I mean, if
Okay.
there's a retake like tomorrow, I think you would do really well on this. But like every problem has a little like wrinkle, a little oddity to it. Okay, so can we move to 4A?
Yeah.
Okay. And that, I mean, that kind of is everything for that one. We already had the graph here. So 4A here. X squared plus 5x minus 24 over 2x plus 2. I really like that you factored this all correctly.
Hmm.
So you did, yeah. So this, I mean, your work is just completely correct. Your cancellations, eh, yeah. So does that mean that you got it right? I don't know. I can't really on your page the where the instructor sort of circled it 4A.
No, she said that was wrong.
All right. So let's look at this again. So it's x plus 8, x minus 3. Oh, I didn't factor this correctly. It's 2 times x. I'm sorry. It's not the right. This is not right. All right, 2x plus 2. I can't even write the problem down. I'd be definitely get a 1 on this problem with your instructor. Uh, all right, x minus 9, x plus 1, 3 times x plus 8. Okay. So you start out by canceling anything that is the same in the top and the bottom. So like that x plus 8 goes with that one, x plus 1 goes with that one. Um, so your answer is correct, but maybe not preferred. Um, like here's what I'm thinking is the instructor wanted to see this, and then you multiply the 2 and the 3 to get a 6,
But I didn't
or
do
what,
that.
what's that?
But I didn't do that.
I know but your answer, like to me, your answer is correct,
Yeah.
but I didn't grade this. Um, the other possibility is they wanted you to FOIL the top,
Oh,
and like I don't know. So I would ask, I guess, if you think this will come up on your midterm final here in a few weeks.
okay.
It really comes down to how they grade. I mean, that's the thing about college. You really are at the mercy of the instructor and how they do things.
Yeah.
And this is, just preparation for that.
Yeah.
And work. You work for someone, they have a way they want you to do things. That's not really up for discussion. Okay. Part B. Part B here. All right, so we have in the numerator x squared plus 3x plus 2, x squared plus 2x in the denominator. You're dividing x plus 2, 3x squared minus 6x. As much as I don't like it, I would recommend flipping this first so that you don't forget to do it later in the problem. So you mentioned like getting lost earlier. I would say it's more that most students there's so many things they have to remember that they get uncertain about what to do because there's so many things going on. And this is one of them. So let's factor here. X plus 2, x plus 1. The bottom, it's x times x plus 2. 3x, x minus 2, x plus 2, like that. All right. I think you did that correctly as well. Let me check there. You just didn't flip the one on the right. So, again, division becomes multiplication by the reciprocal. And now we can cancel. This is sort of the fun, you cross out things. The x goes with the x. So in the numerator, you're left with x plus 1 times, and then the 3 can go out in front, x minus 2, and on the bottom, it's x plus 2. So to me, it looks like you tried to cancel out something in like twice.
Oh, I didn't.
Or you misfactored.
Oh, I erased the Oh, I see what I did. I erased the plus and put a minus instead. I don't know why, but
Do you feel like you second guess yourself on these tests, or do you feel certain about your work as you're doing it?
some parts I feel certain on, some parts I second guess.
There's a lot of research out there that says to never change your answer after unless you know for sure that it's wrong. The research shows it's better to go with your first effort, your intuition, if you will.
Okay.
All right, so I think that takes care of the Unit 2, Part 2B assessment. We're missing like summative or something that they usually throw in on these. Should we go to log practice next, or is there something else?
Yeah. Yeah, we should go to log practice.
Okay. All right. Looks like you've done some of these. Do you need me to check them, or do you feel like the ones you've done are correct?
I think they're correct.
Okay. Then let's start with number 7. I'll stick that in. So we're transitioning like completely to a new topic. Like this has nothing to do with the stuff we just did.
Yeah.
All right. First thing that I see here is this square root. Like whenever you see a square root, you want to treat it as a 1/2 power. So log AB BC to the 1/2 power. And this really helps to simplify what to do next, because even though there's kind of equal precedence, you can move the exponent out in front. So it's 1/2 log ABC like this.
Okay.
And then from here, you separate the product. The product becomes a sum. So it's like log A plus log B plus log C. Now that 1/2 is actually around all of them. It's often, often it'll be misremembered, but it really goes to each one. So your final answer is 1/2 log A, but you're distributing it to all of them plus 1/2 log B plus 1/2 log C.
So if there's so the 1/2, where did you get the 1/2 from?
So the square root up here in the top right, square root always means 1/2 power.
Oh,
So,
okay.
so the square root of x is really x to the 1/2 power. And that applies to the next question. It's a slightly different way of presenting exponents, but we'll look at that one next. Here, or number 9, I guess.
Okay.
All right, so this one, number 9, it's x times y times z to the 1/3 power. And if you're wondering why that is, it has to do with the root stuff. So the root stuff, this is a property you saw earlier in the course. The root, the nth root always becomes the number on the bottom, and the exponent m inside the root becomes the numerator on top. And you might say, well, hey, Matthew, like, where is the m in my problem? Well, it's there, it's just not written. It's really x times y times z to the power of 1.
Oh, okay. That makes more sense.
Right, so now it's very much like the previous problem. You bring that exponent out in front. You generally bring the exponents out in front first. And then the product becomes a sum.
Okay.
So again, it's 1/3 log x plus 1/3 log y plus 1/3 log z. Any questions on that? Any follow up?
No?
Okay. We'll move to 11. All right, so this one's got some numbers. It's got some exponents. Again, you generally want to bring that exponent out in front. It's almost always your starting point here on these problems.
So for the
So for this one, let me give you the property. A quotient becomes a difference. And whatever's up top is the first thing, whatever's on bottom is the second, and you're subtracting. So
okay.
the 11 is like your A minus the bottom, which is 6 to the power of 3. And there's really this 6 out in front.
So you would never combine the numbers.
No.
It's like having A and B, but it's just numbers.
Yeah. Yes. That's the idea, is it's like you want to do something with them, but you cannot. Okay, so from here, I think it would be a good idea to distribute the 6 into both, but you're distributing it in front of the log. So it's like 6 log 11 minus 6 log 6 to the power of 3, like that. But there's one more thing we've got to do to finish this problem here. Let me know when you're caught up.
I'm all caught up.
Okay, so the last thing here is that this exponent here 3, it can also come out in front of this log. So it's
Right.
6 log 11 minus 3 times 6 log 6.
Okay.
And then you do multiply the 3 and the 6. So there's a little more to do. You can combine some of these steps also. But you may want to wait to do that until you've had a bit more practice.
Okay.
All right, so I guess we can move on to 12. 12 is really similar. It's just got a few more letters. We'll look at 12 next. So what do you think we should do first on this one?
Distribute this 6 to both the X
Yes.
and the Y.
So bring that 6 out in front. So it's 6 log X to the 4th over Y.
And then would you do anything from there, or would you just leave it?
You've got the same problem you had in the previous one, which is it's a log A over log B. And
Mm-hmm.
the idea of all these expand problems is that you have a lot of logs that you're writing, and you might have some numbers out in front, but you have no exponents. That should have been stated in class, no exponents.
Okay.
So this becomes 6 log X to the 4th minus 6 log Y. So if there's something out in front, it also goes out in front when you're distributing here.
Oh, okay. That makes sense.
Okay, good to hear. And then the last thing is this 4, this exponent of 4 above the x. It also has to come out in front here. So that becomes 4 times 6, or 24 log x minus 6 log y.
Could you reduce it? No, you couldn't because of its
No,
log and y.
exactly. Yeah. No, it's a good question to ask because there are problems where that might happen, especially now that I know your teacher's style. Yes, you'll probably see that on a test.
Okay.
It's yeah, it's so helpful when I can see the instructor's actual like way they do stuff because then I can help you even I'm not guessing anymore. All right,
Yeah.
number 13. All right, so this is like even though there's an exponent above the 7 and the 5, it's not around the fraction. You have to first separate the fraction. Like the precedence here is like do this first, make the quotient into a difference. So this becomes log 7 to the 4th minus log 5 to the 6th.
Hmm. So you wouldn't distribute the exponent from the
No,
7/4 this time.
no.
Okay.
Yeah, I mean, if you go back and look at 11 or 12, you see that the difference is the exponent was actually outside of it with parentheses
Oh, okay.
versus it's a slight little thing, but it's significant. Okay, so now you can bring that exponent out in front. So 4 log 7 minus 5 log 6 log 5. All right, so why don't you try 16 on your own? Um, uh, it's a lot like the one we just did. That's why I'd like you to try it.
So it would be 3 log A minus 5 log B.
Yes.
Okay.
What do you think of this? This like expand.
Um, I think it's pretty easy.
I like hearing that.
I'm sure it's gonna get more complicated probably
Well,
tomorrow.
it's not supposed to. You end up using these to like solve equations, but it's really not meant to be like this is not you. It's not like the previous. It's not supposed to be like the previous stuff we covered, where it does kind of get more difficult. Okay, let's look at 14 and might be our last one. We'll see. We got for time here. Just again, wherever you see that exponent outside the parentheses, you bring it out in front. So this becomes 4 log 12 to the 4th times 5. And then there's this product property that we looked at before. a product becomes a sum. So you're treating this 12 to the fourth like it's an A, and this 5 like it's a B. Should have wrote that earlier. I think that would have been clearer. So it becomes 4 log 12 to the fourth plus 4 log 5, like that. The product becomes a sum.
Okay.
But there's one last little thing here. You got to bring this 4 out in front. So it becomes 16 log 12 plus 4 log 5. And that is probably all we've got time for tonight.
Oh, okay.
Don't get too sad that we have to stop here.
Okay.
It's this is kind of drudgery, but I get it. That
Yeah.
is probably it. So if you want to get back on 2 a week, I do have some Saturday times available. Sundays getting pretty tough. A lot of people are wanting that as regular times, but also got some times next week, of course. You want to continue. But thanks for letting me help you tonight, Paige, and it's always fun to work with you. I
Yeah.
will see you next time, whenever that is. Hope you have a great rest of your night.
You too.
Okay, bye now.
Bye.